Okay, we have a table here, right? Depending on what kind of possible attack it is, it'll be forwarded to one of the post-processing hash tables in the back end. So why do we use this two-tiered configuration? Because we want to make it run on a high-speed link. Okay, so on the front end, time is the prime objective. Okay, time is, you have a very tight time budget. Okay, so what you want to do is you do the quick and dirty check. Okay, you might arrest a legitimate packet from time to time, but you don't want to thoroughly check if a packet constitutes an attack. Okay, so you want to arrest some suspects there from the traffic flow, and you move them to a back end where you have a little bit more time to perform a more thorough check. Okay, so I think for the high-speed network, this two-tiered approach is appropriate. So we check the speed of the software, and actually we performed a field test on a campus backbone network. At the time of testing, there was 303 megabits per second live traffic flowing in the pipe, and we used a Pentium PC, which has had a 2 gigabit Ethernet interfaces, and we ran 2 separate copies on each of on these 2 gigabit Ethernet interfaces, and there was no packet losses. It was reported from the PCAP library that there was no packet losses in the kernel, and we had no trouble processing the packets from this 330 megabits per second live traffic. And the software was quite lousy back then. It was not optimized at all. Okay, it had a lot of junks in it, but it still ran without any problem on this with this speed. Okay, so after doing this, we could check if our extraction algorithm worked okay. So on the left side, you will see the real traffic, the same visualization that you saw earlier. The right-hand side is a result of extracting only the text from the traffic, okay, using this algorithm. Okay, if you see a packet that has this particular signature that matches with one of the attack types, and you throw that into the back end, and where they get this more thorough check, and after that you can sort of derive this this graph here. It's the data is very small here after extracting only the attack information. So I don't think there is any problem plotting this in real time. This was 2 million dots in a single plot, but this is like 20, 30 geometric entities. Okay, so it was quite fast, and you might notice that okay, I see this very slim bar type DOS attack on the left hand side, but you see a very large rectangle corresponding to it. That's because we did a very poor job handling the outliers. Okay, if you see an outlier, we just draw the rectangle to envelope all of the dots, so that if there's an outlier floating very high up, you will see a rectangle that covers all of the dots. So that's why. And we ran this software again in 2003. We just threw it in some, I don't know, somewhere, and we dug it up in 2003, and we run that software on another trace, and the trace seemed to have this code rate too, and the software had no problem finding it. And this software also generates a text report. It does not just visualize it. It generates a text report for future reference. Okay, so speed seemed to be okay, but one of the things that we couldn't do was evaluate the accuracy of the software, because if you plug that software to the live traffic, you could test the speed, but since you do not know a priori what kind of attacks are in the live traffic, you cannot check whether the software is telling the truth or lie. Okay, so the only thing that you could do is just do the simulation over this software. So you generate the artificial traffic and insert some attack type traffic and see if the software catches it. So we generate the sort of quote unquote internet type traffic, but it in itself, I mean, generating internet-like traffic is a big problem. I mean, it's a very hard problem. Okay, we don't know, how to generate good internet-like traffic. But anyway, we went ahead and generate using the distributions from from earlier works, like we generate the ambient legitimate traffic, and we added in the attacks to that traffic, and so if the software catches those attacks. And we measured the sensitivity, relative error, and false positive rate. And the sensitivity is basically, okay, there were 100 attacks inserted in that legitimate traffic, and how many among 100 does the software catch? So that was the sensitivity. Okay, S is the sensitivity here, D is the number of detections, and M is actually the number of mounted attacks. And the result seems to be that, okay, for some types of attacks, the sensitivity is very high. Okay, the x-axis here is the attack rate over threshold. So it means that, okay, if the threshold is set like 50 packets per second, if the attack goes over 50 packets per second, then it's an attack. So if attack rate, has, is set to 1.2 times the threshold, it seems that, what's that? This with the DOS attack with the variable port number are code with 80% probability. Okay. And if you see, there are the two types of attacks that do not have this problem. Okay. And the source of this problem that you have, sort of lower sensitivity, is that when you generate the signatures, if you show it closely, if you see this example, if you see this packet, it has this port number 90, and it also appeared for the first packet, but they are two different flows. I mean, it originated from different source. They are destined to different destinations, but it happens that they share the same port number. This kind of collision in different flows is quite rare in the IP coordinates, because the IP space is huge. It's 4 billion addresses there, so the probability is quite low. But for destination port, it's only 64K, so the probability is quite high, especially because there are quite frequently used port numbers like 80. Okay. So that's why we get sometimes wrong signature for a packet, and that is the reason that we have lower sensitivity for the port number for the attacks that have variable, this one and that one, variable port numbers. Okay. And the relative error is also high for those two types of attacks that have variable port numbers. But fortunately, the port scan is sort of a minor issue from the perspective of the